Okay, so we've seen this last example quite a bit. The idea is projectile motion. So the idea is we're going to throw a baseball, and this time JoJo's throwing it up, and his physics class models the height of the baseball with the following function, right? H of t equals negative 16t squared plus 88t plus 6. T is time in seconds, and h of t is the height of the ball above the ground when he does this. All right, so how do we use this? Well, if we want to find the height of the ball at 1, we're basically looking at h of 1. So just like we traditionally do with the function, we replace our x value with what we were told to replace it with, and we do the work. So 1 squared is 1, times negative 16 is negative 16, 88 times 1 is 88, and then adding the 6. So we have negative 16 plus, I think 88 plus 6 is 94. And if we do this work here, we end up with h of 1, I believe, equaling 78. Right? And I guess that would be in feet. So at 1 second, the ball is 78 feet in the air according to this model. All right? So that's, again, how we just use the function in terms of what it's giving us. Find the time when the ball reaches its maximum height. Okay, so first of all, make sure you understand that this is a quadratic with a negative leading coefficient. So the height of this, right, this is h and this is time, is going to be parabolic. So to find the time when it reaches the maximum height and to find that maximum height, again, we're basically finding that vertex. So the time of the maximum height will be negative b over 2a. In this case, this is negative 88 over 2 times a negative 16. A negative divided by a negative is a positive, and right away I know 2 goes into 88 44 times. So far we get 44 over 16. And then taking a look at these two numbers, I believe 4 goes into both of them, and so we end up having 11 over 4 seconds. And I'm going to keep it in that fractional form. I guess that's what, like 2 3/4 seconds. So it's going to take 11 quarters or 2 3/4 seconds for the ball to reach its maximum height. Right? What is that maximum height? Well, we basically just have to find s of 11 over 4. So we're going to plug in 11 over 4 and square it, plus 88 times 11 over 4, and then plus 6. If I square a fraction, I'm basically squaring the upstairs and the downstairs. So 11 squared is 121, and 4 squared is 16. Here, 4 goes into 88, I believe 22 times. So we have 22 times 11, and then we're adding 6. Nicely, the 16s cancel out here, so we're left with a negative 121 plus, let's see, 22 times 11. 22, 242, and then plus 6. Negative 121 plus 242, that is 121, and then plus 6, it looks like we get 127. So the time that it takes to reach that vertex is 11 1/4 seconds, and the height that we get to maximize is 127 feet. So yet again, another vertex model where we're basically trying to find that. Okay, so let me stop there. The next couple of questions are a little bit different, and it'd be nice to have a calculator floating around when we analyze this. So I'm going to go try to get my TIA 484 calculator in working order so we can do that, and you can follow my calculations. But there, right, is basically the vertex and the maximum, the optimization problem for projectile. It basically comes down again to finding your vertex. We've been doing that quite a bit. So talk to you guys later.